So my blended course is entitled Engineering Problem Solving with Computers. And it's a course that meets in a computer lab. Unlike a regular course where you might have a lecture and followed by some kind of lab, my course is only labs because the lectures and all the other materials that are associated with it are online. They're contained in the course management system. Well, the original motivation came very long ago. It was back in the 90s when Larry Landweber and I, Larry's a retired computer science professor who was very much involved with the internet, realized that the real killer app of the coming internet was video. And so at that time, we tried to put together some proposals to do video capture and then broadcast this or make it available over the internet. And so that's what got us started. And so unlike a lot of people today, my original motivation was very much technology push. We were interested in the technology. It really didn't exist at the time, and we were in the process of trying to create it. And so one thing led to another, and we got a very substantial National Science Foundation grant and hired expert programming talent to produce a product called eTeach, which was a authoring tool that allowed us to combine video with tables of contents and other online content in order to provide an electronic lecture format. So that was my original intent, but it very quickly transitioned into the realization that the real payoff here was in student learning outcomes, and that the technology itself, while important to get right, was really just a means to an end. And so my focus quickly changed in the late 90s and early 2000s into looking at learning outcomes and student achievement. The big advantages that I've seen are in teaching this course in a way that's most natural to the subject. It's sort of deadly to lecture about computer programming and some of that kind of thing. And so the lectures in the course as it had previously been taught were pretty poorly attended, and students learned quickly that really wasn't very interesting, nor was there much useful information there. It was all presented, but really they had to do it themselves in order to get good at it. It was a little bit like watching somebody ride a bike. Well, okay, that doesn't teach you how to ride a bike. And so you have to do it. And so the idea was to transition the course where more and more of the time in the classroom was dedicated to students actively doing something rather than simply receiving information. And so in our case, at least, the subject matter was such that it was just natural for them to be actively involved in the classroom all the time. And the result of all of that, I believe, and we did some measurements actually with professional course evaluators in the early 2000s and published papers on this, that students did learn more. By spending more time in the classroom, they learned more than spending more time in the classroom doing active exercises and things. They were learning more than just once a week in the classroom doing this while listening to two lectures, or maybe not listening to two lectures. And so that got us into this shift where what we called it at the time was reversing the lecture homework paradigm, meaning that students now did what was the equivalent of a lecture out of the classroom by watching this on video online, and when they came to the classroom, they spent their time doing something active like the equivalent of doing homework problems and such. And so the advantage of them doing this in the classroom is that now they're under the supervision of the instructors, and so we can see what they're doing, we can watch over their shoulders and understand whether they've got the right concept and whether there's just some detail that's wrong or whether they just don't have the concept at all. And so we believe that as a result of all of that, we were able to improve student learning outcomes. I never was trying to reduce costs. That was never a goal I had. It could have been a goal. It just wasn't, in my case, a goal. I know it's more important today, and people are looking hard at how to make that happen. And I've done this for a long time. The first time we taught this class this way was in 1999, and so I've been at this for 13 years for the same class. And so over that period of time, what I've done is evolved dramatically. since the early days. In the early days, I thought the video was the important thing. Today, I know the video is not the important thing. What I believe is the important thing today is assessment. That is, measuring what students are learning and doing that in a very continuous way, so that it's not just a midterm and a final exam, but that every step along the way, I'm getting feedback on what the students' learning patterns are. And so the course as it stands today has 87 learning modules that are covered over the 14 weeks of the semester. And every one of those learning modules in the course management system, which is Moodle, but it could be any course management system, has a quiz associated with it. And the quiz is due before students come to the lab, where they're going to be working exercises that have that learning module as background. And so in recent semesters, I've seen a dramatic improvement in the performance of students in the lab itself, because they just don't have as many naive questions as they've had in the past, meaning that they have actually looked at the material before coming to the lab. And I know that because they don't ask as many questions about, in the case of computing, it's syntax questions. It's just, what word do you use in the computer language, or what punctuation is there in this arcane computer language that has to be there for the computer to understand what you've typed. There aren't as many of those questions, and that's because all of that kind of low-level learning, just the rote stuff that you have to know in order to accomplish something, is the kind of material that's online. And so by essentially forcing the students to look at all of that before coming to the lab, I've improved their performance in the lab. And so my analogy is always related to sports. It's like they did all of the work in the weight room or in the practice field or whatever you want to call it, all right, before they got to the actual game, so that when they arrived at the game, they were prepared to actually play the game, which in my case is working on the exercises in the computer lab under the supervision of myself. If one wants to try to inch out some cost savings in all of this, I can imagine that by improving the preparedness of the students before they come to the lab, I can actually teach more students in the lab than I might have previously been able to teach in the same time, because I'm not getting as many naive questions, and they're not getting stuck on such simple issues as they were in the past. And so my labs meet twice a week for 75 minutes. And so again, in my case, there's no class time savings in what I'm doing, because I still meet with them for the full time for the 3-credit class. It's just that our time is much better spent. Another way that I like to put it is, if you want to teach your child how to shoot a basketball or something, then do you just sit in front of the TV and watch somebody play basketball, or do you go out in the backyard and work together on how to shoot a basketball? And so I think that shows that there may be some value in watching what someone else does a little bit, but in the end, you don't really get to the end game by doing that. You're just doing that entirely. You have to go out and do it yourself. I don't teach the course in a completely asynchronous way where different students can move forward at different paces, but it could clearly be done that way. One thing that I do in the lab is the students work in 3-student teams, and I do a little social engineering where I pick students from the top third of the class, or at least as I estimate it, and put one of them on each of the teams. And I choose someone from the middle third and someone from the lower third. And so I kind of have de facto team leaders on each team as they're working together on these problems. And then that helps me to sort of scaffold their local expertise with my help in coming around. So during a lab, I will indeed spend more time with the students that are struggling in that lab than I do with the ones that are not. And I often find myself apologizing at the end of the day to the students in groups that are doing quite well, and I'm telling them that this is the way it is. If you're getting it on your own, then you're going to largely be left alone. I come around a little bit and try to add some value by pointing some things out, even though they're getting it all correct. But I spend my time with the students that are having more of an issue with the material. And so that way, I think that's time better spent because everyone is sort of being dragged along, and hopefully that equalizes the rate at which they're all, getting to the material. Now, one thing that I did this last semester that I've never done before, because this is all online, I did offer a second section of the course that was completely online. It was like a distance learning course. And I had 4 students sign up for that. 3 of them were kind of special cases, and one of them was in my regular section and decided after the first week that he didn't really need to be there, and so he switched over to the online section. And so those students were not required to come to the lab. Now, the labs are where I think the really important stuff happens, but if you are comfortable enough with computing that you believe you can do this on your own, then I allowed those students to, in sort of a synchronous way on a week-by-week basis, to just work through all of the exercises. They took all the same online quizzes. Every lab that is done in one week has a quiz about it in the next week, and so all the online students are required to do all of that. And so all the grading, with the exception of the attendance at the labs, which I also grade on attendance in the labs, were covering the same material. And that worked just fine. It really did. The grade distribution of the 4 students that were doing it online was fairly comparable to the students that took it in the lab. I had one guy that was just spectacular. I had someone else that was, really very good. I had a third student that was kind of average. I had a 4th student that struggled a little bit, but they had a real special circumstance and really had to take it online. But it proved to me that I could offer this course to 400 students if they wanted to take it online. There was because the scaling was completely there. It's all electronic. My quizzes are all electronic. Homework is submitted electronically into a Dropbox, and so except for the grading of the homework, there was a lot of scalability to what I was doing. So I will continue to do that and offer it that way. Another option that holds open is the idea that I could offer this in the off semester, because this is a fall course. The enrollments in our department are sufficiently manageable that this is taught once a year, not twice. But if I had a group of students that for some reason were out of sequence with their curriculum and needed to take this class in the spring semester rather than the fall, there's no reason that I couldn't do it now. And the incremental cost, workload associated with that would be fairly minimal. It's also a sophomore class in engineering, and we have a fair number of students that transfer into engineering having taken their freshman year somewhere else. There's always the possibility that they could take this course online before they even showed up to campus, and then they'd have one more course under their belt before they got started here in our curriculum. So, I can imagine that there's a lot of potential advantages to doing this that haven't been explored yet. The blended learning approach completely changes the face-to-face teaching, because early in the development of this course, we of course eliminated the lectures because those are now online, and so that's this reversing the lecture homework paradigm thing, as we called it. But today it's commonly called flipping, is the terminology that's used, but it means the same thing that we did back in 1999, and so it means that we devote all of our effort to this active learning part of the course rather than simply information delivery that you might have had in a lecture. And so that is, just dramatically changed the way we did this. I briefly experimented with the idea that I could teach this with less contact hours, so that we had 2 labs that met for only 50 minutes a week. And so it was only 2/3 of the contact time for a 3-credit course. And I didn't feel that worked out so well. And I also, on the balance of things, felt that I could do a better job if we did this for 2 75-minute periods, and so I do that. Now, I think that the other reason that we have the 75 is that I'm teaching this class to 12 groups of students, each of whom are clustered as 3 around computers. And so there's 36 students in the section. And that is about as much as you can do, because I'm running from one group to another, helping them with places that they're stuck, and they're writing computer programs. And so if the program doesn't work, then they really are stuck. And I have to be on top of this enough to figure out what's wrong and basically debug it for them as they're there, or offer, helpful hints and let them do it themselves, which is what I do. But it means that you can sometimes get stuck with one group for some period of time. And there's no way around it, because if you walk away from them, then they're just going to sit there for the next half an hour with nothing to do. And so, it's a little bit like air traffic control. You really can't take your eyes off the screen, in my case 12 screens, for very long. And so the reason it's taught for 75 minutes is to give me enough time to get around to all of those groups. If I had only 6 or 7 teams, I could probably teach the lab in 50 minutes and do just as good a job. And so there's a little bit of student to faculty ratio going into this. So that's the way it's done right now. I think that as we continue to improve, particularly in student accountability and their assessment and their preparedness for the labs, there's all kinds of ways you could imagine trying to build them up step by step to be prepared for the lab, in which case, if that was done online in some fashion, then perhaps we could reduce the amount of time in the lab. Now, the other unusual thing about this class is that it's not taught by TAs, all right? The other flipping, if you will, is that in a typical college course that involves a lecture and a lab, professor teaches the lecture where there's very little contact with the students, and the people that have the greatest contact with the students are the teaching assistants, who are graduate students. And in my case, because I don't lecture at all, I put all of my time into the face-to-face time in the computer labs. And so I get a closer relationship with the students and with their student learning than would be typical in the way a conventional course operates. Well, clearly DoIT is a resource in this area. The staff at DoIT have all kinds of knowledge about the various technologies and such, and so that's important. I think DoIT has instructional designers, if one wants to go that far, to design courses. In my case, I got started on this so early that I just made every imaginable mistake that you could make, and so over 13 years I've made enormous numbers of mistakes and then corrected those and gone on. And so I've sort of, I think, kind of separated out what I think in my own mind works for the kind of course that I teach compared to what I might have been trying to do previously that had the best of intentions but didn't work very well. And so I think that one of the pieces of advice I would give is, one is to have a set of goals for what you're trying to do. If what you're trying to do is improve student learning outcomes, then that's a goal. If the goal is truly to reduce costs, then you have to somehow reduce instruction time, because instructor time, because that's where most all of our costs are. I mean, the cost of the building doesn't factor into the way we compute course costs, and so it's largely just the cost of the instructor. And so you have to do that, and that's another goal you could have. And I guess I would say finally that there's also a lot known about this now, and so it's not an unknown art. And I would really urge people to get advice from others that have done this, and from experts and members of the university staff that have the job description of helping people do this. I think that that's a very valuable asset that one should take advantage of. Just starting with a blank piece of paper and deciding what you're going to do to transform a course from a conventional teaching approach to an online approach or a blended approach is probably not the right thing to do. You're going to spend enormous amounts of unproductive time doing that, compared to investing a little time up front, exploring this with people who've walked down those paths before and made some mistakes, and they'll tip you off to what not to do. That what not to do might be as valuable as what to do, and then I think you can make a much more efficient process out of this than what I experienced over a decade now.